India Semiconductor Mission is well covered by Vinodji, and we'll go to the next step. Now, when we want to design any electronic system, there are basically three components. The first one is hardware design, and this is before like you do some simulation, and then you design the hardware part in the software, and then you design the software part also of that which will control the hardware, and then a firmware which will be lying over the both together. So this is a very, I mean, there can be multiple steps or components, but I have tried to, give a main three components for any electronic hardware design part or system design. And then it happens with the concept of what you want to do, what you want to develop, and then you design in the software, and then you make a prototype. Now, finally, it is tested, and when it is, able to deliver whatever it has been designed for, then it goes to the next level of production likewise. So this is how a cycle of system design take place. And then it is not that simple, like shown in the previous slide. There are different challenges. So one is first is complexity because I mean, now people are looking for a very small miniature components and a very high quality of the electronics item or customer experience, consumer experience. Everything inside, for example, an aeroplane have a 51 antenna, or your mobile phone has more than 5, 6 antenna, one for Bluetooth, one for navigation, GPS, one for Wi-Fi, other for cellular communication, likewise. So multiple complexities are involved or in the system designing. And then the other component is once you design and produce the equipment, it should be well in the time to the market, because if you are not able to deliver your equipment, instruments or consumer goods in the time to the market, there is no point of developing or producing them. Overall, it should be very cost effective so that people get the advantages at the of using it. If it is expensive, probably the success rate will be slower, and then it should be very reliable, because once people invest for any equipment, any instrument or any electronics good or system, they feel that it should be very reliable and stable. So these are the challenges which need to be address when you are designing any electronic system. And once the design and prototype is taken place, then you have to test it for different functionalities which has been designed here. So it should be technically feasible is the first consideration we should look forward for when selecting an test and measurement equipment. That means like whatever it is designed intended for that, is it meeting the requirement or not? And it should be also very effective. The expensive equipments will not able to deliver the cost effective the consumer goods or electronic system. And it should be future scalable. For example, today if you are developing a 5G smartphone or a smartwatch which is supporting the LT call, tomorrow it should be on the 5G network, and maybe going forward after a few years it may be at a 6G also network somewhere, or a dedicated mission critical communication network. So the equipment should be fully scalable to meet the requirement of future needs. And then finally, it should be very easy to use, very less time to learn the how to operate it, how to uh, do the functions, and less skilling should be there. That will actually make the success of any test equipment selection. These are the key criteria for selection. Now, here we will give you an overview that from Anritsu side, we are involved in the industry, electronics industry, from R&D to mass production of lot of equipments. For example, left-hand side, you can see the smartphone is there. So tablet or cellular module, which are installed inside car or any other devices. On the right hand side, you can see the test equipment which are primarily required for any individual testing. If it is a research equipment, it should be very highly accurate and have a lot of functional and reliable test reports. When it comes to the production, it should be a multi-port devices, because time is very important or critical in production. You have to produce devices around the clock, like 24/7 factories are operating. So it should be able to test more and more devices. And at the production, you only need go no go kind of testing. While in the R&D phase, you need a very detailed R&D or test equipment to test each and every parameter defined by the standard bodies. It may be 3GPP, it may be PCI SIG, or it may be Bluetooth, or it may be USB LANs, or likewise. And the first and foremost component in an electronic system is actually IC, integrated circuit. We know, all of us, this is very important. So here it is a system or a process which is showing that how it is designed and tested. So pre-silicon verification is done, and then it is on the kind of software only. And ASIC means like application specific integrated circuit. And then it goes to the post silicon test, where you need a test equipment, number of test equipment. It may be a BERT, bit error rate tester, or signal quality analyzer, and real-time oscilloscope or vector network analyzer for validation. When the IC tape out is clear, it should go to the mass production. And in mass production, like earlier I mentioned, there will be equipment which have a multiple port for testing. And then finally, there may be a system level test. For example, that IC is now fitted into a system, it should be again tested. So these are the different stages where we see any kind of high-speed digital system or any electronic system is tested, and what kind of test equipments are involved at various stages. And the product which we mentioned in the previous slide is targeting the like AI data center or edge AI, artificial intelligence, edge computing. Vinod sir mentioned already, these are the trending, emerging technology. High speed devices or internet access is now required at every place. So this equipment give you the data rate testing of 400G, 800G, which is very, very really high data rate. And any kind of the USB device, for example, in from phone or from PC, we want to transfer any data to any other storage devices which have a USB port. So it should happen in very less time. And that is how the testing happens when the any USB is being designed. Likewise, jitter tolerance is also tested in the any USB device or any other receiver device. Nowadays, we are also having a PCI, peripheral computer interface Gen 6, which is already in the place, and devices are being tested by different players like Cadence, Frambus, those kind of guys who are producing the high speed buses. And all this equipment, when our IC is being produced, different quality of material is also being tested. And there are a few equipments which are primarily intended for testing the material quality only. So one of them is, we called it network analyzer, vector network analyzer, VNA, because we are already talking about millimeter wave and terahertz in the academics for research of 6G. Or FR3 frequency range. So we need a very broadband VNA which should be able to test the material from say very basic frequency to the higher frequency. So we have a VNA which works up to 220 gigahertz without any expander. Or if you want to test anything which is beyond 220 gigahertz, like in the range of sub terahertz, so we will provide an extender module which will give you the extended frequency operation of material testing. And likewise, on the optical side, there are active cables or direct and active electrical cables, or copper cables, or DAC direct attach cable. They are used in data center server racks to connect each other, and they are tested with this VNA on the right hand side, top one. And at the bottom there are test equipment which is called part of optical VNA, we call it, because as I said, optical devices will be playing a role for high speed internet access. At the back end, the optical devices like O to E converter, optical to electrical, or electrical to optical converter, they should be also tested to handle the higher data transfer rate. And this is the equipment VNA is used for that purpose. And below you can see a very basic diagram, and on the left hand side as a concept side, on the right hand side you will see the actual real diagram of VNA, you testing one material for high frequency with our VNA. And like artificial intelligence, AI is increasing. So semiconductor materials has been tested already, but after the fabrication of the device or final device, we have different testing equipment for different stages, as mentioned earlier in the slide. Vector network analyzer, VNA, and signal quality analyzer, they will be used for different data rates depending on technology. And on the right hand side, if you see the bird wave MP2110A, which is a like multi-channel equipment for testing the optical and electrical high-speed devices. So this is primarily used in the production testing. And for data center also similar equipments are used, but one new equipment is introduced at the bottom line. We have covered already the top line, but bottom line is like optical spectrum analyzer. So when you have the optical devices or modules, for example, SFPs or data cables, high-speed data cables, the spectral study happens with the optical spectrum analyzer. When the network is deployed, you have to test the throughput, latency, all those parameters in the network side. So right hand side, we have the handheld field testing equipment, which is used by data center commissioning people or the people who integrate the data center or hyper connected world, where one data center is connected to the other data center on a higher speed. So different tests are being conducted with this handheld equipment that is good for field and also for the lab, because this is battery operated and power, and the AC means power operated. And now we will be covering the wireless devices production. In particular, wireless device may be our smartphone or tablet, which is supporting the cellular technologies like 2G, 3G, 4G, or 6G, or new sub 6 gigahertz 5G bands. And it may be having a Bluetooth or wireless LAN connectivity. On the navigation side, as I said earlier, it may be having the GPS or GNSS rated cellular and plus navigation box tools inside, ICs inside. On the right hand side, like access point Wi-Fi router we already have at our home. For broadband, it will be also having the different IEEE, supporting specification, Wi-Fi specification. And then at the same time nowadays, fixed FWA, fixed wireless access from 5G. So it will be having both cellular plus short wireless. And then IoT modules are there for say asset tracking. They are also using the connectivity modules on the lower frequency like Zigbee and GPS for navigation, but on the connectivity side, they are using say 2G, 3G, 4G, and even 5G sub 6 gigahertz. And the narrowband IoT devices, they also use these modules. And the latest traction is towards the automotive electronics, that is used in the telematics, which is a connectivity module for navigation related things, GPS module. And for safety, V2X, like radars are there, so they will actually detect how close is the object and apply the brake in the case of autonomous cars. So all these are having some kind of connectivity as a wireless device that will be tested with equipment shown in the middle. We called it MT8870A. It's a universal wireless test set, because I mean, all kind of wireless testing, whether it is a short wireless or cellular wireless, it will be tested. And you can see multiple ports are there here in this box. So it is truly good for a production testing. That's what I mentioned earlier. And similarly, if you are making, for example, Samsung is our customer, Foxconn, who is making Apple phone in India, they are our customer. They are using these two boxes in production testing or final QA testing of the smartphones, being like we are using in India. And it supports all the things you can see in the center, whether it is a cellular technology like 5G NR or the Wi-Fi different standards, even backend LTE, LTE advanced, and even 3G also WCDMA. And then on the navigation side, GLONASS, GPS, Galileo, all those things. On the entertainment side, FM testing is also possible. On the Bluetooth testing on the same box. That means you don't need a multiple box for just a production testing. A small form factor, multiple port make it ideal for any production testing of any wireless device. We have a very good install base in India for this equipment from production side. Likewise, you can see the traditional method for testing a Wi-Fi router where there are multiple antennas. They are combined with the different divider and splitter. But if we have a multiple port device, each antenna can be connected to the individual ports, whether it is a 2.4 ISM antenna or it is a cellular antenna on 5 gigahertz or 6 gigahertz, even Wi-Fi antenna, and sub 6 gigahertz from the cellular 5G antenna, which is will be a two-in-one kind of router which will support the cellular plus Wi-Fi related connection. So this box is an ideal solution in production testing because of its capability of supporting multiple standards and the multiple ports. And we have the one other equipment which is on the component testing side. For example, we called it Shockline VNA, that is used for testing of the antenna. As mentioned, the aeroplane or any mobile device or any other device, it will for sure have at least one antenna, minimum antenna. It may be a dedicated antenna or a multi-band antenna for different purposes. So that antenna is tested with the VNA, and antenna bandwidth, impedance measurement, cable fault location, where is the fault if there is a connector, an antenna connected by a cable, then what is the cable phase, cable return loss, all those are tested with this equipment. We called it Shockline VNA. This is available in different formats. You can see on the picture. Right hand side, it is one port, very small, easy to use. Multiple can be connected together. In fact, one of the iPhone vendor in Taiwan who makes the antenna for iPhone and other OEMs also, and they use this multiple equipments for testing in production on this kind of equipment. Then we have two port combination, we have four port combination also for different type of devices. The reason for using this equipment in R&D and production is it is very easy to use. You can see it's not like a complex, and then it is also giving a cost value proposition, very small form factor. Depending on the size and space available, you can use either of the model. And yes, of course, this gives a very good cost effective solution for production and R&D testing. We have supplied a lot of these VNS to academics in India and outside India also for research work in antenna lab or microwave lab inside India and outside. And like different connector manufacturers, they also use these VNAs for testing in R&D and production. And now we are covering the very important aspect of 5G. This equipment on the left hand side is a base station simulator, network simulator actually, and it is used for testing the base station. So again, for production, you need a multiple port. You can see here there are four ports and four base station modules can be tested at one go. So what happens once the base station one is being set up
Madhukar
and
sir, uh,
initialized
Madhukar
and
sir,
tested?
can we take a 3 to 5 minutes break, sir? Just to
Yeah, yeah, as you wish. Yeah, no problem.
I'll take up some questions, sir. Habib Khatun is asking, sir, if you could give some details about 3D IC packaging. Do we have that in your presentation, sir?
Not at maybe post presentation.
Arun ji, would you
We
take
can
it?
connect and then
Sure.
uh,
So I
yeah.
think, sir, it's 8:47. Let's connect at 8:50. Let's take a 3 minute bio break right now.
All right. Okay. Yeah.
Sure. Right. Welcome back, participants. I can see some questions in the chat box, and let me see if I could. Uh, yes. So, Varunji, I'm unmuting you. Yes. So I can see some questions. So, participants, these equipments and products shown by Anritsu uh, has an objective of why we are sharing, why Mr. Madhukar Tripathi is sharing these products with you is something that Varunji would be highlighting. There is a very strong reason behind this because I'll unmute Varunji and Madhukarji to.
Yes, yes, yes. So, Madhukar ji, if you can just carry forward this presentation quickly, so then I'll take over. Madhukar ji,
Hello?
are you online?
Yeah, I'm here. Can you
Yeah.
hear me?
Yes, yes, yes. We can hear you,
Okay.
Madhukar ji. It was such a nice presentation. I was just engrossed in it. So the importance of this of showcasing these products is that these products are the core of electronic system, not only design but also testing and manufacturing. So right now, what in India we are trying to develop is the manufacturing ecosystem for the electronic systems and semiconductor industries. We already have got a lot of engineering talent which are stuck up in the back-end design activity. So, but what essentially Government of India wishes to do is to develop the ecosystem for manufacturing. So when this presentation was being showcased, the whole idea was to let the participants understand that how complex it is to manufacture and do the testing. Anritsu is one such company which provides such high level instruments to companies like Foxconn, Samsung, and AMD, which are into essentially, and Samsung also, which are essentially into the manufacturing activity of electronic system designs. So, Madhukar ji, if you can just conclude in some of your slides of
Yeah.
what we have in the store.
Oh, great.
Yes.
Yeah, thank you, Varunji, for making it very
Yes.
short.
Yes.
Yeah, overall, yes, we have the test equipments which are primarily focused for electronics industry, telecommunication industry,
Mm,
and we are very much familiar and known in the market. Like you can see the screen, all the global giants like Intel, Qualcomm, MediaTek, and XP, or even Indian operators like Jio, Airtel, or manufacturers like Sterlite Technology, HFCL, all these people, they are using our test equipment at different stages, testing the electronics and communication. On the government side, AI, or private side, Indigo, Bharat Electronics, Bell, ISRO, Indian Army, Navy, all those people, they are using our equipments for testing their test setup. And it plays a very important role actually in the overall success and customer
yes.
experience. A good testing equipment only provides that experience and ensure that the product quality is very good.
Mhm.
With this, I'll conclude my presentation.
Mm,
My contact is here. If
sure,
we want to get it connected, my
sure.
email ID, phone number, people can reach me. We can address. We work very closely with academics and industry for this. Once again, thank you, Varunji and Sumiji. Yes.
So thank
Thank you,
you.
Madhukarji. Thank you so much for your